So here we have another example of a derivation with biconditionals. So we'll say show the conclusion. The conclusion is a biconditional. There it is. There's no assumption to be made because we're not trying to show a conditional. So we'll bring in both of our premises. Okay, now we have if P then Q, and we have if not P then not Q. We don't have what we need to apply CB. In the previous derivation, if you'll recall, we had if P then Q, and we had if Q then P, and we were able to apply CB to both of the conditionals, and we were able to get the biconditional. But unfortunately, right now, we have this on line 2, but we don't have this. So what are we going to do? Well, if we got this, we'd be able... If we had P, we could apply modus ponens. If we had not Q, we could apply modus tollens. If we had not P, we could do modus ponens. If we had not Q, we could do modus tollens. But we don't have any of those, so we can't do modus ponens or modus tollens, unfortunately. But if we had if Q then P, we could apply CB, and we would get our conclusion. We have this, we don't have that. So this is what we want. So on the one hand, we're stuck because we can't apply any of our inference rules in helpful ways. So we should do a subderivation. And we just figured out what we should do a subderivation of. We should do a subderivation of if Q then P, because if we complete it, we can't immediately box and cancel, but we can apply CB to get P if and only if Q, and then we can box and cancel. So let's write that out. We'll say show if Q then P, and remember if you right click here, you can get this palette to put in symbols if you need it. Right click. Or secondary click if you're on a Mac, whatever the secondary click is. Okay, so now we're trying to show a conditional, so we'll make an assumption. We'll say Q. Now we want to see if we can use Q with our old lines. Can we? Well, not with line 2. For modus ponens with line 2, we need P, and Q is not P. For modus tollens, we need not Q, and Q and not Q are the same thing, and not only that, but we cannot get not Q from Q. So 5 will not interact helpfully with line 2. What about line 3? Well, for modus ponens with line 3, we need not P, and Q is not the same thing as not P. Or we need not Q for modus tollens. Now 5 is not negation Q, but with double negation we can turn 5 into double negation Q, and now we can apply modus tollens with 3 and 6, which gives us not P. Is not P helpful? Well, if we remove the double negations, we get the consequent of the conditional we're trying to show, and that means we can do CD. So there we have if Q then P. Okay, now we've completed this subderivation, so this, and we've boxed this because it relies on this. We can no longer appeal to this reasoning inside the box because it relies on this assumption, which we're no longer making. So we're going to go ahead and close that up. And now we want to use this new line immediately. And what do we want to do with it? Well, we want to put it together with line 2 to get CB. And we'll get P if and only if Q, which is our conclusion. And there we have a direct derivation. So this is an example where, if you remember from the video, you have to do a subderivation of one or two of the conditionals that make up the biconditional to infer the biconditional. In this case, we were half lucky and half unlucky. We had one of the conditionals, but we didn't have the other conditional, so we had to do a subderivation of it, so we used 3, and we used 3 with our assumption to get to P, which gave us if Q then P, giving us the conditional that we wanted, and then we were then able to put 2 and 4 together to get the biconditional that we wanted to complete the main derivation. So that's the kind of thing you'll need to do in some of your homework derivations with biconditionals. You'll need to do subderivations where you make up the subderivation line, and the subderivation line you make up is, you will do a subderivation of, do we care about the spelling? Sure, we do, but not that much. We'll do a subderivation of 1 or 2 of the parts of the conditionals that are part of the biconditional. And so here we do that with line 4. If Q then P is one of the conditionals that's part of line 1, and so we do a subderivation of it that we can then use it with the other conditional to get the biconditional, which is what we are really after. Okay. Hope that's helpful. If you have any questions, please let me know.